Thank you so much. Okay, good afternoon, everybody from ITCSE Conference 2023. My name is Tengjie Q. Today, I have the honor to present our solution to the increasing number of the mental disorders among seniors. We want to create a more trustworthy solution for caretakers to determine the emotion and feelings of their patients. Although the concept of mental health has been emphasized among adults or adolescents, the mental well-being of senior citizens often seems to be overlooked. While society recognizes the importance of mental health, there are still existing risk factors that contribute to the mental disorders among the elderly. Family factors plays a crucial role in the life of older adults, and the profession study consistently emphasizes the correlation between mood and the overall well-being in the older adults, underscoring the seriousness of mental illness in this population. For instance, studies have shown that the older individuals with mood disorders tend to have a lower height, weight, and pressure, and higher pressure. It is important to prioritize the examination and treatment of the depressed elders to mitigate the risk adverse outcomes such as inflammation. By recognizing the correlation between mental and physical health of the older adults, we can work towards providing a better care and support for this vulnerable demographic. Here are some examples of previous approaches scholars have investigated. A study conducted by Wang and Yujimoto aimed to investigate the mental health of aging adults during a simulation process after migration. They focused on the role of resilience and coping mechanism, particularly within the context of cultural heritage, to identify factors that can affect the mental health of Asian American elderly. However, they acknowledge the limitation in building resilience as it heavily depends on the availability of coping resources, such as social support from friends, family, and ethnic communities. Furthermore, Tai Sally and his team examined the care provided to adults with mental disorders during doctor visits using video recording. Their findings indicate that only a small percentage of topics discussed during these visits focus on mental health, suggesting that mental health office are lacking the awareness of others' potential mental problems. Moreover, the notion of seniors' mental policy lens introduced by McCourt and Corco was used to reflect the values and perspective of older adults regarding their mental health. The SMHPL was designed to provide policymakers with an overview of mental health needs among seniors, aiding in the identification of relevant issues. In order to address the mental health problem among elderly individuals, the solution being proposed by this report is the creation of a mobile application that utilizes sentimental analysis to provide feedback regarding the current mood of the speaker. Checking the mood of elders in a daily pattern could prevent the potential isolation that they may feel, especially older adults, particularly those over 80, seems to be more reluctant to seek treatment for psychological disorder. This application enables users to examine and checking seniors' mood based on the tone of their voices. In other words, the application offers a convenient way to determine the mood of seniors. This application enables a collection of daily data of the elderly people, which could be effectively stored and analyzed by professionals to analyze the possibility of potential mental illness. It is being able to digitally track and analyze this data can aid a lot of operation in hospital or care center. For example, the interaction between owners and users that occur could possibly eliminate the loneliness and isolation that older adults may feel. Furthermore, the daily examination of the mood would help the user to identify the potential mood disorder earlier. On the other hand, utilizing a mobile application and the sentimental analysis algorithm could also minimize the bias made by our brain, preventing the user from making assumptions on the mental state of their parents or family members. Overall, with the help of this application, users could effectively determine the mental state of elderly people, eliminating their potential bias through technological aid. This examination also provides the opportunity for the user to discover mental illness in the earlier state. During the process to investigate and develop our solution, we faced several challenges, including analysis of the tone and the ideal length of the audio. Let's begin with the challenge with interpretation of the tone. One important part of the program that measures sentimentality in voice input is the way it analyzes the tone and the pitch of the voice. A challenge that could come up is the quality of the recording itself isn't good enough, making it hard to analyze the tone and pitch accurately. To fix this, the program we could use noise detection techniques or suggest that the user re-record with a better audio quality. With multiple algorithm and noise reduction techniques could help improve the sentiment analysis accuracy in the voice input. On the other hand, the length of the recorded audio may also lead to a concern about application. In other words, if the audio being recorded is short, sentimental analysis lacks enough data to report an accurate solution. After all, the accuracy of the application should be prioritized. Meanwhile, if the user records the audio longer than expectation, the data will take a wait time in order to be transmitted. To resolve this potential issue, we conduct experiments, which I will later address in the presentation, and aim to determine the shortest recording with enough data for sentiment analysis to examine. Our solution is being written in the Flutter framework and open source UI software development toolkit. The application itself is being programmed in Dart because it's computer availability with Flutter. Generally speaking, there are three major components that are essential to this program: login, sending out, adding patient list, and audio analysis. The program is designed to be available for users to download free on their devices. As the user opens the application on their mobile device, the splash screen will first be shown. Then the application directs the user to the login screen. If the user does not have an account for the application, they could obviously sign up with the sign up button and create an account with their email and appreciated password. Furthermore, once the user successfully logs in their account, the application will be displayed the list of parent, patients, and family members that have been previously saved if available. On this page, the user could also choose to add a patient/family member by pressing the plus button. In order to proceed with the functionality of the program, the user could select a member from the list and enter the chat page, which offers the opportunity to record the audio of that patient. After recording is done, the result processed by the sentiment analysis reports the type of emotions being found, which display on the screen. Based on the audio being recorded, the result could be neutral, happy, sad, or etc. The account credential of the user is being stored at a database called Firebase. The credential include user's email, passwords of account, and a unique UID to identify the user and their corresponding data. Here's some example of the UI. This code selection shown in this slide clarifies the functionality of adding data in the list. This code requires the user to enter three basic information about the parent, patient, or family member that they are trying to add: name, age, and gender. These three input values are later saved in variables sent to database. After the user is press the add patient button, the patient/family members will appear on the main page for the user to start recording the audio. Moreover, this section of code shown will be used after recording is completed. The method send audio file represents the process of sending the audio file to the sentiment analysis located at Amazon Web Services. The variable URL and requests are used to request the server for the result of analysis. Furthermore, this method also checks if the upload is successful. By comparing this static code, the method will report if the audio is being uploaded or upload failed. As previously mentioned, AWS, Amazon Web Services, serve as a storage for the sentimental analysis. While saving the analysis in a cloud, the program will be more efficient and lower the risk of function failure. After the analysis of the recording is being completed, a feedback will be sent back to the program, which later being displayed on the recording page of the application. One potential blind spot while testing a program that measures sentimental analysis is the potential bias in the training data, which can result in inaccurate sentimental classification for certain demographic or cultural context. It is important for the program to work well in order to provide fair, unbiased analysis results that they are accountable for a diverse range of users. To ensure the accuracy of the sentimental analysis, a systematic testing approach will be employed. The testing procedure will involve utilizing pre-test dataset, compressing audio recordings, each associated with a specific emotion. For instance, if an audio clip exhibits a happy tone, it will be labeled as a corresponding happy emotion. Subsequently, this audio file will be subjected to a sentimental analysis algorithm, and generated result will be compared to the expected emotion. This process will be repeated for a sample 5 recordings. By calculating an average from obtained results, we can test the performance and accuracy of the sentimental analysis program. With the length of the recordings being 4 seconds, the result or somewhat surprising, as only 6 out of 10 recordings are accurately classified. Enhancement to the algorithm are crucial in improving its accuracy and dependability. The primary factor influencing the result is the accuracy of the sentimental analysis algorithm. By enhancing the model's capacity to handle a wider range of voice characteristics, optimizing the audio processing techniques, and utilizing high-quality training data, more precise classification outcome could be achieved. Furthermore, in the context of a research paper experiment focused on an app that calculates people's sentimentality based on the audio file, it is important to address the potential issue of the time required for the audio being processed. The duration of this analysis process may pose a challenge, as the user might experience delays for the app to provide the results. This could potentially impact the user satisfaction and overall app usability. Therefore, it is crucial to investigate and explore methods to optimize analysis time, such as employing efficient algorithms, and leveraging parallel processing techniques, or utilizing cloud-based computer resources. To test the time it takes to analyze audio within sentimental analysis or algorithms, we design a quick experiment. We will select a set of voice recording of different length, ranging from short to long. Time will vary from 3 seconds to 1 minute. Each recording will be sent individually to the algorithm, and the time will be taken to process each audio file will be recorded. We will repeat this process for multiple recordings to gather efficient data. By analyzing the time taken for each audio length, we can identify any pattern or trend in the processing duration. This experiment will provide insight to the relationship between the length of the audio input and the time required to the sentiment analysis, enabling us to optimize the algorithm's efficiency and scalability. Upon analyzing the data, we observed that the algorithm exhibited a constant processing time for a shorter recording. For instance, the sentiment analysis algorithm responded to a 3-second recording in 2 seconds and a 10-second recording in 4 seconds, indicating a relatively low processing time for these shorter durations. However, as the length of the recording increased, we noticed a significant increase in the processing time. For example, the sentiment analysis requires 35 seconds to process a 30 seconds recording, 82 seconds for a 45-second recording, and 122 seconds for a 60-second recording. This trend suggests that longer audio file requires more computational resources and time for the algorithm to analyze and determine the emotion. The data highlights the need to consider the trade-off between processing time and the desired length of audio input. If the real-time or near-instant analysis is crucial, shorter recording will be more suitable. On the other hand, if the accuracy of the pretenses over processing time, longer recording can be utilized, recognizing the increased processing duration entailed. Further optimization of the analysis algorithm may be necessary to improve the efficiency and reduce the processing time for a longer recording. This mobile application designed to help families and care teams to determine emotion of particular others. Overall, the mental health of seniors should be highlighted in the society. In order to raise the awareness of mental health among the others, we developed this mobile application using Flutter to provide a way proceed to an early diagnosis. In general, this application has a few major components, include sentiment analysis, which has been examined for its reliability. Compared with other methodology posted by research team, this application is more sufficient in a small group of people, suggesting our application could be used in families or elderly houses. Here are some of my references. And thank you so much.